So the questions for now are going to be, I want us to find the center and the interval and radius of convergence. All right, and like I said, this is like the first main standard problem type, like first major homework type problem. And so we're going to look at the sum k equals 1 to infinity of 1 over k times x minus 8, let's make that 6 to the k. Okay. So one of those three things, so we're looking for three things: the center of the power series, the interval of convergence, and the radius of convergence. Okay, so one of those things you can get by just looking at it. What can we get by looking at it? The center is what?
X minus 6.
Oh, okay, it comes from x minus 6, but the center itself is 6 because it's like what makes it 0. Okay, so the center is 6. In order to find the interval and radius of convergence in general, what we do 90% of the time or 99% of the time is we use the ratio test. In a few cases, we might use the root test, but the general approach is to use the ratio or root test. The root test would be used if everything is to the k. Otherwise, we use the ratio test. So we look at the limit as k approaches infinity of the absolute value of ak plus 1 divided by ak. The reason that's a good idea is because one of the things we said yesterday about the ratio test is that we use it when you have exponentials where the base is not 1 or negative 1. Well, x minus 6 to the k is an exponential where the base is probably not 1 or negative 1. So that's why the ratio test is a good call. So we're going to do limit as k goes to infinity of x minus 6 to the k plus 1 over k plus 1 times k over x minus 6 to the k. Okay, any questions on how to come up with that? Okay, and just so you guys know, if you're typing stuff, I'm only on my iPad today, so I can't see any typed comments. So if you do have a question, just unmute yourself real quick. Okay, so we're gonna simplify this down by splitting up the exponentials. So we're gonna make it x minus 6 to the k times x minus 6 to the first over k plus 1 times k over x minus 6 to the k. The point of that is to get the x minus 6 to the k's to cancel. And now we're going to figure out some stuff about this. Any questions to hear? Okay, so at this stage, you should try to figure out two things. One thing you should figure out is what stuff can come out of the absolute value because we know it's positive, and then what stuff has to stay in the absolute value. And then the other thing is what parts are not affected by the limit. So the limit is what's happening as k approaches infinity. If something is constant with respect to k, you can probably pull that out of the limit. So let's start by looking at the first thing on top. So the first thing on top is x minus 6. So do we know whether x minus 6 is positive or negative? We don't, because x is a variable and x is not approaching infinity. So we don't know whether x is positive or negative. So that means that x minus 6 has to stay in the absolute value, but x minus 6 does not change as k approaches infinity. So you can pull that out of the limit. So you pull the x minus 6 out of the limit, but it stays in the absolute value. Okay, the other thing on top is k. Because k is approaching infinity, we know k is positive. And so you can take k out of the absolute value, but you cannot take k out of the limit because it's as k goes to infinity. Same thing on bottom. K plus 1 has to be positive as k approaches infinity, but so it can come out of the absolute value, but it does change as k goes to infinity, so you leave it in the limit. Okay, any questions to there? Okay, the limit as k goes to infinity of k over k plus 1 is 1. So we get absolute value of x minus 6 times 1, which means from the ratio test, we get the absolute value of x minus 6. Okay, any questions so far? Okay, so what this tells us is that no matter what x is, you get the absolute value of x minus 6 when you apply the ratio test. So let's say that back up here, so we don't need to do this to solve the problem, but let's say back up here, the series had been 1 over k times 14 to the k. Okay, in that case, x would have been 20, because that's what you would plug into x in order to get 14. So if we had done this series, we would have gotten 20 minus 6, or 14, from the ratio test. So does this series converge or diverge? How do we know it diverges if you get 14 from the ratio test? What's the ratio test tell us? Somebody knows. Nobody knows.
Bigger than 1.
If it's bigger than 1, it diverges. Okay, so what we're trying to figure out is what makes this converge. So then what we want to know is, when is this limit at the end less than 1? Okay, so we're going to try to figure out what makes that less than 1. And so just real quick, as a quick algebra review, the way that you solve the inequality there is you say, okay, if the absolute value of x minus 6 is less than 1, then that means x minus 6 has to be between -1 and +1. Everybody clear to there? That then means that 5 is less than x is less than 7. So you add 6 to all 3 parts. Any questions? If you think of that on the number line, the center we said was 6. This goes from 5 to 7. So from here, the radius of convergence is what?
1.
The radius is 1, because it's the distance from the center to either endpoint. Now, the problem is that the ratio test yesterday we talked about said that if the limit is less than 1, the series converges. If the limit is equal to 1, the series diverges. I'm sorry, if the limit is bigger than 1, the series diverges. What happens if the limit is equal to 1 on the ratio test?
We need to use a different test.
We need to use a different test. So in this problem, when x is 5 and when x is 7, you actually get 1, which means all of this ratio test stuff does not work. So what you do is you independently test the 2 endpoints. Okay, so we independently test 5 and 7. So I plug 5 in to the original series. That gets me 1 over k times -1 to the k. That is then -1 to the k over k. And then when I put 7 in, I get 1 over k times 1 to the k, but 1 to the k is 1. And so I get 1 over k. Does that make sense? What does the series when x equals 5 do? So what does this series do? Does it converge or diverge?
Converge.
It converges. And the reason it converges is, man, both good guesses, but it does converge. Sorry, Hussein. Converges because it's one where you would take the absolute value diverges, but then this converges conditionally by the alternating series test. Does that make sense? Everybody clear? Okay, the one on the right diverges because it's the harmonic series. And so then when we do the interval of convergence, the interval starts at 5 and stops at 7, and then somebody explain why I would choose to use the symbols that I used on the interval of convergence. Why a bracket on 5 and not on 7?
Because at 5 it converges.
At 5 it converges. So remember we're describing, when we're doing the interval of convergence, we're describing all of the values where the series does converge. It does converge at 5. It does not converge at 7. So we include 5. We do not include 7. Okay, any questions on that problem?
Doug, can you
Yep.
go over how you got from the last interval, how you
Last
got like
interval.
between -1? Yeah,
How I got that?
like how you did the algebra for that.
Okay, so when I'm doing this step, in general, when you have the absolute value of, say, whatever is less than, say, a positive number like 17, then, like, Carson, if you think about what that would mean like, okay, if here's 17, all of these numbers like 16, 15, 14, all of these, the absolute value is smaller than 17. But you go back to -17 because, like, if you look at -18 or -19, those absolute values are bigger. So you want all the values in between -17 and +17. That's where I'm getting this. And then I add 6 to all 3 parts of the inequality. So I get 5 and then X and then 7. Does that answer your question?
Yeah, thank you.
Does that make sense? Yeah, no problem.
Yeah.
Okay. Any other questions to there? Okay. I want to go through another example, and then I want to talk about some stuff, some other stuff that can happen. Man, I lost my example. Let's do this one now. Okay. All right, so let's go through problem 2. So same directions, we're finding the center, the interval of convergence, and the radius of convergence. So number 2 is going to be the sum k equals 0 to infinity of -5 to the k, x plus 2 to the k, over the square root of k plus 4. And we're looking for the center, the interval of convergence, and the radius of convergence. Real quick, what is the center of the series?
-2.
-2, good. All right, so the center is -2. I think when you're doing the homework, I forgot to ask for the center on the homework, but I think, are we all comfortable doing that? You probably have to tell what the center is on the test, just so you know. On the interval of convergence, we should start with ratio test. So we do limit as k goes to infinity of -5 to the k plus 1, x plus 2 to the k plus 1 over the square root of k plus 5 times the square root of k plus 4 over -5 to the k, x plus 2 to the k. All right, questions? Okay, so we're going to split up the exponentials to get the stuff to cancel. So we go -5 to the k times -5 to the first, x plus 2 to the k times x plus 2 to the first, square root of k plus 5 on the bottom, and we get that stuff on the right. The -5 to the k's cancel, the x plus 2 to the k's cancel, and then nothing else cancels. Now we can figure out what to pull out of the limit and what to pull out of the absolute value. We know that I'm going to choose to leave 5 in the limit, although we could pull it out. But we know the absolute value of 5 is 5. So I'm going to leave it in, but you could pull it out. You can pull the absolute value of x plus 2 out. You should do that. And then the square root of k plus 4 and the square root of k plus 5 have to stay in the limit, but they can come out of the absolute value because they're positive. So you can either have what I have, or you could pull the 5 out with the absolute value and just have the 2 square roots inside the limit. Any questions on how to get to there? Okay, what is the limit part of this? So we're going to get the absolute value of x plus 2 times what in this case?
5.
Times 5, perfect. So then that's 5 times the absolute value of x plus 2. And now again, we want to know, when is this less than 1? And the reason we want to know when it's less than 1 is because this is what you get from the ratio test. So if it's less than 1, it converges. If it's greater than 1, it diverges. If it's equal to 1, we need to independently test because the ratio test doesn't work. So now we divide by 5 first. And now x plus 2 should be between negative 1/5 and positive 1/5. And I know this is weird algebra that most of us have not seen in quite some time. So please ask if we're not clear. Is everybody good on that? Okay, now we're going to subtract 2, but I think of 2 as 10/5. So we get negative 11/5 is less than x is less than negative 9/5. We're subtracting 2 from all 3 parts of that inequality. Now, you don't need a graph, but I think it's easier to think about when we think about a graph of a number line. And so you want to think, okay, where is the center? And then where are these things in relation to the center? So negative 9/5 is the same thing as negative 1 4/5. And negative 11/5 is the same thing as negative 2 1/5. So what is the radius of convergence based on that diagram?
1/5.
1/5. Again, the radius of convergence is the distance from the center to either endpoint. Any questions on that? Okay, why do we not have enough information to complete the interval of convergence? So we know it starts at negative 11/5 and it stops at negative 9/5, but we don't know whether or not to include those. So we independently test them, and this is a little bit harder on this problem. So we plug in negative 11/5 for x first. And so that gets us the sum negative 5 to the k times negative 11/5 plus 2 to the k over the square root of k plus 4. That gets us negative 5 to the k times negative 1/5 to the k. But then negative 5 times negative 1/5 is positive 1 to the k. Make it clear that's not a negative, that's positive 1 to the k over the square root of k plus 4, which is then 1 over the square root of k plus 4. Does that make sense? What does that series do? Does that series converge or diverge? It diverges because it's one where you would compare to 1 over k to the 1/2, which is a divergent p-series, and then this would diverge by the limit comparison test. So that one diverges. Now you do x equals negative 9/5, and so you get negative 5 to the k times negative 9/5 plus 2 to the k over the square root of k plus 4. That's negative 5 to the k times 1/5 to the k over the square root of k plus 4. That's negative 1 to the k over the square root of k plus 4. That series converges conditionally because it's one where if you took the absolute value, it would diverge, but then you go back and do the alternating series test and the series itself converges conditionally. So we include -9/5. We do not include -11/5. And so the interval of convergence goes from -11/5 to -9/5, where we include -9/5. Okay, I know that's a lot, so please ask questions if we have them. Everybody is comfortable with this.
So whenever writing out okay, you have it up at the top, right? The interval
You're
of
good.
convergence.
Yeah. Yeah, so like the answers are here.
Yeah. Okay. Just on the last problem, you didn't. I didn't see if you wrote that out or not.
You're good. I thought I did. Yeah.
Okay.
Yes.
Yeah.
Like that.
Never mind.
All good. Don't worry about it. Other questions?
Would we have to show those tests within, or can we just think about it?
Ben, that's a good question. So when you're talking about these down here, normally I would say you do not have to show the test for those. Given that this is an open book, open note test where you have 24 hours, I would say probably you do need to show those. Does that make sense?
Yeah.
Okay. Most of the time I would say no. And when you see my solutions, I probably have written like this diverges, and then maybe I list the tests that you would use. I'm not sure if I list that or not, but I would definitely not have shown the detail. But given that it is a take home for 24 hours, I would plan to show that. I have still not seen the test, so I don't know for sure whether they're going to specifically ask that, but I would go ahead and plan on that. Does that make sense? But like these should be now like stuff we've done before. It's just you have to simplify them down first, and then they're going to be anything other than the ratio test, because we know from back here that you get 1 from the ratio test at those values. Does that make sense?
Yeah.
Okay. Other questions? Okay. Now I want to talk about what else can happen here. So the two that we've done are the hardest possibilities. So on both of the examples we've done, we've gotten it down to something where you have this inequality less than 1, or you have this absolute value less than 1, and same deal here, you have this absolute value less than 1, and then you have these endpoints to test. It's not always that hard, but when you get to here, when you do the ratio test, you're going to get like the absolute value. So let's say, I don't know, let's say that you have the sum bk times x minus 7 to the k. Okay, so first of all, for that series, no matter what bk is, so maybe this is really hard or really easy, doesn't matter. Okay, no matter what, what's the center of that series?
7.
The center is 7. And then you would do the ratio test. So you do the limit as k approaches infinity of the absolute value of ak plus 1 over ak, and then you do lots of steps, and then you get, let's say you get the absolute value of x minus 7 times the limit as k approaches infinity of k over k squared plus 2. Okay, so let's say you get that. In that case, everybody get what I'm saying? So the circled step that I've got up here, I'm saying this is what you get at that stage. Well, I guess back here. This is what you get at this stage. Does that make sense? Okay, so if that's the case, what do I get for the limit?
1 over
So
k.
1 over k, which is then what?
Divergent.
The series is, but not the limit as k goes to infinity. You're good.
Oh, yeah.
But so what is this limit equal to?
0.
0. And so then what's the absolute value of x minus 7 times 0?
0.
0. Okay, everybody clear so far? Okay, so if you work it out and you get this, you get 0. And you're trying to figure out for what x values, so you're thinking for what x values is that true? So how often is 0 less than 1? Always. And so if that's the case, then the interval of convergence is all real numbers. Does that make sense? The radius is how far it is from 7 to infinity and how far it is from 7 to negative infinity. How far is it from 7 to infinity? Infinity. And how far is it from 7 to negative infinity? Infinity. So when you get 0 here, the radius of convergence is infinity, and the interval of convergence is everything from negative infinity to infinity. The other thing that can happen is you can have this whatever times, say, x minus 10 to the k. And so the center is 10, and you work it out and you do the limit as k approaches infinity of the absolute value of ak plus 1 over ak equals blah, 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 equals, and then let's say we get the absolute value of x minus 10 times the limit of, as k goes to infinity, of 3k to the 4th plus 7 over the square root of k to the 6th minus 1. And so if that's the case, you get infinity. Does that make sense? What we want to know is for what values is that, that true. Okay, so for what x values is infinity less than 1? Infinity is never less than 1, right? Infinity is never less than 1. So when that happens, the interval of convergence is the single number 10, not always 10, but always the center. The radius is the width of the number 10. How wide is that interval?
0.
0. Now, I want to talk about a couple things. One is, why would this for sure have to converge if I put 10 in there? What happens?
We're multiplying it by 0.
You're multiplying all the terms by 0. So no matter what, every power series must converge at its center. This one up here has to converge at 7 when x is 7. It does, it converges at everything, but it must converge at 7. This one converges nowhere except 10. So the one on the bottom converges nowhere except the center. Everybody clear? Okay, now these two cases are technically easier, but they're also easier to get backward. When you get 0 as the answer, when you get 0 from the limit, the answer is infinity, or negative infinity to infinity. When you get infinity, the answer is 0, and the interval is a single number. And so it's just easy to get it confused, but like these cases are easier because there are no endpoints to test. Does that make sense?